Quero dizer a todos que, com a criação do Núcleo de Pesquisa Mackenzie em Ciência, Fé e Sociedade, Discovery Mackenzie, a Universidade Presbiteriana Mackenzie pretende oferecer ao Brasil, e quem sabe ao mundo, a oportunidade de pesquisadores, de pessoas que efetivamente estão buscando alternativas para o conhecimento humano, possam desenvolver suas atividades de pesquisa na direção da ampliação da teoria do design inteligente como alternativa ao ensino que é proposto, especialmente no Brasil, nestes últimos anos. E queremos desejar que este curso seja extremamente proveitoso para todos nós, que este curso seja relevante, a fim de que nós sejamos capacitados para não apenas formular nossas pesquisas, mas especialmente para transferirmos o conhecimento adquirido para outras pessoas, em todos os cantos. Nós queremos dirigir uma breve palavra de oração e encerrar assim esta nossa saudação. Nosso Deus e Pai, bendito é o teu nome. Nós te agradecemos pelo privilégio de podermos estar em tua presença e, especialmente, termos a oportunidade de ouvir nossos palestrantes no dia de hoje, deste curso que desenvolve os fundamentos da teoria do design inteligente. E nós queremos agradecer ao Senhor, porque o Senhor nos dá a possibilidade de avançar dentro do campo científico e de vasculhar aquilo que parece não ter fim para o conhecimento humano, pois é descobrir as características da natureza, avançar no conhecimento das propriedades naturais daquilo que certamente veio da tua mente. E nós pedimos que este dia seja um dia de intensas reflexões, que nossos palestrantes tenham a grata alegria de ver suas palestras repercutindo nas mentes e nos corações dos nossos pesquisadores aqui presentes. Abençoa todos nós, pois, te amamos e te louvamos por esta graça recebida. Em nome de Jesus. Amém.
Iniciando as atividades do nosso curso, convidamos ao palco o professor Dr. Marcos Eberlin.
Então, nós vamos dar início à primeira palestra. O Brian Miller, please come. It's your time now. Ele vai falar sobre a teoria do design inteligente. A ideia do curso, só deixando bem claro, é que a gente conheça bem os fundamentos da teoria do design inteligente, a gente saiba bem o que é e o que não é a teoria, quais são os seus pressupostos. Então, o treinamento é esse, para que você saia daqui pronto para defender a teoria como ela deve ser defendida, tá bom? Bom curso a todos.
Thank you. It's such an honor to be here. Today, what I'll be doing is talking about what is the theory of intelligent design. And what I'll do for you is talk a little bit about the history, then talk about why there is such opposition to it, and then give you an overview of what is the research being done and has been done in the field of intelligent design. So hopefully this will help give you a good introduction to the overall project and maybe even give you a sense of how you can participate in it. Well, I first became interested in the whole debate on intelligent design when I was a freshman in college, because I attended MIT in the United States. And what happened is my freshman year, I had read a book called The Blind Watchmaker by Richard Dawkins. And what Richard Dawkins argued is that when you look in nature, you think you see design, but it's all an illusion. It's all a misinterpretation. In fact, everything in nature can be explained by chance, time, and natural processes. And I remember, as a freshman, realizing if that thesis is true, then that means I'm simply an accident of nature. I have no purpose, there's no meaning to life, I'll eventually die, and then all my memories will cease and everything will end. Now those were very dark thoughts as a freshman, but that's a logical conclusion of the idea that we're simply an accident of nature. So I realized that the most important question I had to address was, is life designed? Is it the product of some intelligence? Or is life simply a product of the natural forces? Natural forces working with natural selection and mutations. Well, what was interesting as I started to research this topic is I realized that this debate had been going on since the ancient Greeks. If you go all the way back to 500 BC and earlier, what you find is different Greek philosophers debated this very same topic. Some believed that there was some rationality to the universe, and that rationality explained why you see design in nature. Other Greeks denied that, and other schools of thought argued that everything can be explained by material processes, chance, and time. In fact, the ancient Greeks even had an early version of evolution and an early version of natural selection. So when Darwin came on the scene, this wasn't a debate that came out of thin air, but it was almost a repeat of history in many ways. Because at that time, the philosophy of materialism was becoming more popular in Europe. And essentially, materialism is the idea that all that exists is matter and energy. There is no outside intelligence or agent that's influencing the world. Now, what Darwin did was he actually gave a more rigorous scientific explanation for that idea. And to begin the discussion, I want to talk a little bit about the logic of Darwin's view of evolution. Now, what happened was at that time period, when people looked at nature, they saw what appeared to be amazing design in life. A bird has wings to fly. It has many special adaptations, like hollow bones, that enable it to perform that task. So it looks like a bird is something designed by an agent with a purpose in mind. Now, what Darwin did is he turned that idea on its head. Now, the way it began is Darwin looked at what was described as crossbreeding, or in a sense, artificial natural selection. And the idea was that if you were, let's say, a farmer that raised sheep, what you could do is you might want more wool on your sheep, because then you could sell more wool to people that made clothes. So what you would do is you would crossbreed sheep so that you would look at the sheep that produced the most wool, mate them with other sheep that produced the most wool, and then over time the offspring would produce more and more wool. And people saw that as a beautiful example of how you could apply design to life to produce something that you desired. Well, what Darwin thought is perhaps the same process could happen without a designer. So for instance, you could imagine that there's a series of winters that were colder and colder, so the sheep with more wool outsurvived those with less wool. So what you saw was that selection was acting on the variation in the species of sheep, and over time it produced sheep with more wool. So again, you don't need an intelligent breeder. Natural processes can do it blind. Now, this was a very remarkable shift, because what he was doing was he was saying that when you look at nature and you see evidence of design behind how well species were adapted to their environment, that appearance could be an illusion. It could actually be produced by the natural processes that happen every day. Now, what he did was he took what he observed with sheep, what he observed with things like finches, and he extrapolated that over time. So perhaps the natural selection you see in a short period of time to produce a woollier sheep or produce a finch with a larger beak, perhaps that could accumulate over a long period of time and produce all of the major life forms we see today. So the basic idea is that you have, long ago, the origin of life. There was some cell that happened long ago, and then over time that cell became more complex and split off into the tree of life, where the major branches represent the major divisions of life, like animals, plants, fungi, and so forth. And then, of course, each branch broke into smaller branches, and that would break into those smaller divisions of life, and that's the iconic Darwin's tree of life. And again, what happened was there were people that promoted Darwin's theory not solely because they appreciated the science, but because they wanted to remove the idea of design from the world. At the time, there were forces that were hostile to faith, they were hostile to religious structures. So again, people like Huxley, who was described as Darwin's bulldog, vigorously promoted evolution because they realized that if you could argue against the appearance of design and say it's simply a product of natural processes that mimic design, you could help remove the idea of a creator from culture. And of course, that wasn't solely the motivation. Like natural selection, in many ways, was true in a very good science when you're dealing with small-scale change. So it actually was very, very helpful in many ways. But the extrapolation to the major changes you see in nature, like going from an amphibian to a reptile, that was something that created an enormous philosophical shift in culture. Now, some people that were religious didn't have a problem with it. They were trying to accommodate the idea of evolution with their beliefs, but then other people recognized that there was a very deep tension, that it was very difficult to argue that we're a product of the blind forces of nature that didn't have us in mind, and that we were created by a creator that had a purpose for our lives. So what you find very early is there was a lot of religious opposition to evolution, particularly in the United States. And what you had is organizations that tried to attack evolution, but often the attacks weren't done by people that were credentialed scientists. Often they weren't done by experts in the field. So it became, at least in the United States, almost a cultural battle between religious people and then people that were promoting the mainstream science. And that's very unfortunate because that's how the debate has often been presented, that it's an issue of faith versus science. And often it was presented in the idea that if you're a person of faith and you're a person that's less rational, that you're motivated by religious beliefs, or if you're a person by science, you're motivated by truth, by logic, and by evidence. But in fact, that dichotomy is completely false. What you find is that there were other people that critiqued evolution. And that's really what is the heart of the intelligent design debate. It's not a religious critique of evolution. Intelligent design is not based on religious scripture or an attempt to defend a certain interpretation of Genesis or the scriptures of other religious beliefs. What it is a scientific critique of neo-Darwinism and a scientific critique of the idea that the blind forces of nature can produce the appearance of design. So it's a scientific enterprise. And the goal of the intelligent design movement is twofold. One, it's to point out the limitations of purely materialistic forces. And two, to point out how there's rigorous scientific evidence for design in nature. In fact, if you look at the very same logic used by historical sciences like geology, and you apply that same logic to life, the conclusion is that you see signs of intelligence which are really undeniable. Now, to give you a little history of this enterprise, is a lot of it goes back to the mid-'80s. And there was actually a chemist by the name of Charles Thaxton. And what he did is he wrote a book called The Mystery of Life's Origins. And what he did is talked about how examining the origin of life from the perspective of a chemist or even from a physicist, what you realize is that life seems impossible to begin through purely materialistic forces. In fact, what you see in life is the idea of information which points to design. And I'll talk about that in more detail through the talk. Now, also, what you find at the same time period is you find a person named Michael Behe, and you may have heard of him because he spoke last night. And what he talked about is that when you look at biological systems, what you see is characteristics which cannot be explained purely through materialistic processes. They seem to defy the logic of neo-Darwinism, of evolution, and instead they point to the idea of design. And if you were here last night, you heard him explain that basic idea. Well, also what you find is other authors came on the scene. There is a man named Philip Johnson, and he wrote a book called Darwin on Trial, and that book critiqued the logic of evolutionary theory as it was portrayed to the public. In fact, he was a lawyer, he was a law professor who had clerked for a Supreme Court judge, and he talked about how evolutionary theory is largely based on circular reasoning. You have certain assumptions about the idea of what natural selection can do, and you essentially assume from the beginning that natural selection can do anything, and then you conclude the same thing because that's what you started with your assumptions. It was circular logic. Now also, what you find is other authors came on the scene to talk about the evidence for design. People like Bill Dembski. And I'll mention some of his theories of how you can actually present a scientifically rigorous method for detecting design. And what happened is these arguments started to sway people. It was essentially the arguments were taken out of the confines of a religious discussion and brought into the scientific mainstream. And what happened was something quite remarkable, is there was a man named Anthony Flew. And Anthony Flew was one of the most avid proponents of atheism. He was a philosopher. He spent his entire life coming up with arguments to defend the idea that there is no creator. What happened was he started to read the literature of intelligent design authors. And he actually went to the lecture by Charles Thaxton. And what happened is near the end of his life is that he renounced his atheism. He actually believed that there was some intelligence behind life because, again, when you look at the cell, you see things like information, you see complexity, you see irreducible complexity. So these arguments convinced this world-famous atheist that design was real. Now, at that time, intelligent design became much more popular in the media. In fact, if you look at a lot of news articles from the New York Times, you look at TV interviews, what you see is design theorists were presenting their ideas to the public. Now, what happened was this created an enormous backlash. Because again, when you look at the scientific community, at least in the United States, in Europe, and other parts of the world, the unofficial faith of the academy is materialism. So the underlying assumptions that people believe when they do their research is that there is no outside intelligence, no outside agency involved in the world. And evolution, Darwinian evolution, functions as the creation story of that philosophy. So the response wasn't purely from a scientific critique, it wasn't simply scientific disagreements, but it was almost much more like a religious crusade. There was a deep threat against their entire view of reality. So what happened was when you look at the response against people that promoted intelligent design, it could often be quite dramatic. And one of the most interesting examples was a man named Richard Sternberg. And Richard Sternberg was an editor for a journal at the Smithsonian. And what happened was he actually allowed a scientific paper by Stephen Meyer to be published in his journal. And Stephen Meyer, who is in charge of the science part of the Discovery Institute, who I think many of you have heard before, he talked about when you look at the Cambrian explosion, which is a sudden appearance of new body plans in the fossil record, it looks like it was designed for various reasons. And Richard Sternberg thought that the arguments were sound. It was peer-reviewed. It went through all the scientific process appropriately. However, when it was published, Richard Sternberg experienced what could almost be described as an inquisition. People started to investigate him. They saw that he actually went to church. They started to present misinformation about his motives. They presented rumors attacking his credibility, and he essentially was driven out of the Smithsonian and essentially made an example of for anyone who dared to question the Darwinian orthodoxy, which was really unfortunate. And if you look at the news media, often after that point, intelligent design was portrayed as simply religious zealot, was simply portrayed as a religious movement in an attempt to impose religious doctrine on the public. And the scientific arguments were largely ignored by the press. And that's the largest challenge. The challenge faced by scientists that see the evidence for design is not the strength of their arguments. It's more of the misinformation presented against them and against the arguments they're trying to make. So we're very encouraged because in Brazil, in other countries, there is more of an openness to pursue the truth. There's more of an openness to pursue where the evidence actually leads, even if it questions the underlying assumptions of people in the academy who may, as a matter of faith, deny the possibility of intelligent agency. So you're in a very exciting place. So what I want to do now is talk a little bit about what are the scientific arguments for intelligent design and what research is actually being done. Well, I have a background in physics, so some of the arguments that I find most intriguing in along my specialty is with the issue of the laws of physics. Because what scientists have realized over the last century is that the laws of physics seem to have been very carefully designed with life in mind. In other words, if you imagine that you have, let's say, a computer that generated universes, and on that computer you had many knobs, many dials, which controlled the laws of physics for the universe you were designing. What has to happen is you have to get dozens of dials just right to create a universe that allows for life. In other words, gravity has to have the right strength. The mass of the proton and neutron have to be just right. The force attracting a proton and electron has to be just right. Now, some of these dials, you can imagine, go from, let's say, 1 to 100, and the dial has to be set at, let's say, 77. That's like the mass of a proton. If the dial was at 78 or at 76 and your universe was produced, you wouldn't have the atoms necessary for life. You'd either have only hydrogen or you would have no carbon or helium or carbon or oxygen, which are essential for life. Other dials are much more precisely set. In fact, if you're trying to design your universe and you're trying to set the force of gravity, the precision necessary to get gravity right for the universe to support life is similar to trying to hit a target with a rifle at the other end of our galaxy that's 1 centimeter by 1 centimeter. That's the precision necessary to set that parameter for the universe to support life. And then also, if you look at the many details of our Earth, our sun, our moon, our galaxy, there's hundreds of details that have to be perfectly set or else life would be impossible on our planet. So in other words, when you look at virtually every aspect of the laws of nature, they seem to have been carefully designed with life in mind, and particularly intelligent life. And that was something that was extremely encouraging for me as I was looking into these arguments. Well, in addition to that, when you look at the structures in the cell, you see features that point to design. And Michael Behe talked about this last night, but just in case you were not here, as a quick review, if you look in the cell, you see what are called molecular machines. They're not like machines, they are machines, just much more sophisticated than what we can create. And this is actually an outboard motor. It functions the same way, and it spins, and it allows for the cell to move in a liquid medium. And this particular structure has multiple parts, and all these parts, most of these parts have to be there at the same time for it to function. And that's really not something you can explain through a Darwinian process of gradual improvement where you add one part, then another part, then it improves over time, but dozens of parts have to be there at once, in the right order, assembled in the proper way for it to function. And again, that points to agency, it points to intentionality, it points to goal-drivenness, which essentially is characteristics of design. Now, again, the argument was made not just from an engineering perspective or a logical perspective, but also from a mathematical perspective. There is one of our colleagues named Bill Dembski, who's a mathematician, and what he realized is that when you look at mathematical theorems related to things like genetic algorithms, what he found is that natural selection is always very, very limited. In other words, this graph represents what's called a fitness terrain. So if you look at these axes, it simply represents all possible animal or plant life or other organisms that could exist. And the height represents the fitness of an organism. Now, if you look at some species, something like the example of sheep, what happens is your population of sheep resides at the top of this fitness peak. And what happens is natural selection is very good at improving a given species by making very, very small changes, like more wool, perhaps a finch beak, which is larger. What happens, though, is that if you try to go from, let's say, one peak, let's say an amphibian, to another peak, let's say a reptile, it's impossible to happen through any sort of natural selection process because you tend to reach the top of a peak and get stuck. And the time scales required to search all of the space is far beyond the time available in our universe. And essentially what happens is to get from one peak to another peak, you have to have information for what you're looking for. In other words, if you're going from, let's say, an amphibian to a reptile or from a fish to a human, you have to have an intelligent agent that infuses information into the system to guide it to a new peak. So again, from a very rigorous mathematical formalism, you can see that natural selection cannot work to produce large-scale change without design. Now, Bill Dembski also talked about what was described as a mathematical or a logical formalism for how do you detect design. And what he did was he looked at fields ranging from archaeology to forensics to the search for extraterrestrial life. And what he realized is that whenever you're trying to identify design, you go through essentially a similar process. And he described this process as a design filter. And the basic logic is you ask the question, can some pattern, can some artifact be explained by natural processes? So if you go to the beach and you notice ripples in the sand, those ripples in the sand can be explained by wind and waves and different features like that. If you look at a mountain and you see sort of a rough patch on the mountain, that pattern can be explained by erosion and natural processes. Well, if you look at a pattern that can't be explained by any natural process, then you ask the second question. Is that pattern highly improbable? Is that something you'd expect to see purely by chance? So an analogy would be, if you, do you have alphabet soup? Have you ever seen like soup with letters in it? So if you happen to have alphabet soup and you started to stir your alphabet soup, you might see the word Bob. And if you happen to have a name like that that's very short, it might look like it's designed. But Bob is not very improbable. It's something that could happen purely by chance. So when you look at something that's very short, it's not something that could happen, it's something that could be explained through a natural process. But what if you saw, let's say, the first paragraph of Romeo and Juliet in your alphabet soup? Well, that pattern is so improbable that you know it can't be explained by chance. Also, if you see that pattern, you know that you can't explain the first paragraph of Romeo and Juliet by the organic chemistry of the pasta or the physics of the boiling water. So it's a pattern that can't be explained by any natural process, by chemistry or physics. It's a pattern that's highly improbable. And lastly, it's a pattern that demonstrates specificity. It's a very specific arrangement of letters that achieves a functional goal. It's called specified complexity. It's complex, but lots of patterns are complex, like random letters, but it's also specified in that it's a very specific sequence that achieves a functional goal. Now, I showed you before a picture of that bacterial motor. Now, if you look at a bacterial motor or any structure in the cell, what you see is they're largely made of what are called proteins. That's the building block of a cell, much of the brick and mortar. There's other chemicals too, but that's the majority. And what happens is you ask yourself, how do these building blocks work? How is it that you have this bacterial motor where you have something like a hook that has the right shape, the right physical properties, that properly connects to other pieces in your motor? Well, the way it works is all of these building blocks of the cell, these proteins, they have a very specific sequence of building blocks or letters which are called amino acids. So that's essentially your building block of a protein. And these amino acids have to be in a very specific sequence for them to form a structure that works properly in the cell. So what happens is when you apply the design filter to something like a protein, you see evidence of design. Because there's no natural process that's going to put a bunch of letters in a very specific sequence to achieve a functional goal. Also, if you look at how rare these proteins are, in other words, if you took a random set of letters and you put them in a line, you connected them together, what's the likelihood that this sequence of amino acids would form a functional protein that would do anything useful? And the odds are fantastically small, and that's something that Douglas Axe will talk about a bit later. Now, also, you see that there's evidence of specified complexity or a goal, which again points to a design. Now, this argument was made by another researcher who I mentioned, who was Stephen Meyer. And he used a similar logic, but he came about it from a bit of a different perspective. And what he did is he looked at the issue of the origin of life. And he didn't simply look at the proteins, but he actually looked at the DNA. And that's significant, because a challenge when looking at the origin of life is even if you have a cell that functions perfectly, like you imagine in the early Earth, by a miracle, all of the pieces of a cell came together and it worked perfectly. The challenge is the building blocks of a cell break down. They break apart. So you have to constantly replace them. And the proteins and the building blocks of a cell don't self-replicate. They don't duplicate themselves. So you have to have the machinery in the early cell that can produce new building blocks for the cell. And that means that that information that tells you how to construct a protein has to be stored in what's called DNA. Now, when you look at DNA, DNA is a molecule which is made of what are called nucleotides. And what happens is the importance of what happens in DNA is beyond its chemical properties. What happens in DNA is you have these nucleotides that function like the letters of an alphabet. Now, in proteins, you can have 20 different amino acids. So it's like English language. You have over 20 letters, or Portuguese, or Spanish. Most language has certain numbers of letters. So we have 20 in proteins, but in DNA, you have 4 letters: A, C, T, and G. And what happens in proteins, or in DNA, is that the sequence of amino acids in your protein, essentially the letters of your sentence, are translated into the letters of your DNA. So what happens is every amino acid corresponds to 3 letters in DNA. It's called a codon. And that translation is what stores the information for your proteins, and then you have a way to get that information back through a lot of molecular machinery. Now, what's interesting about this is that there's no chemical connection between your amino acids and your series of nucleotides. So if you had, let's say, a vat of these different codons, and you filled that vat up with the amino acids, you would not see the codon associated with the amino acid strongly attracted to it any more than any other amino acid. That's really significant, because what you're dealing with is something that's like a computer code. If any of you program computers, you know that 1s and 0s in a computer correspond to letters in the alphabet. So if you type in a sentence, that is translated into 1s and 0s in your computer code. And that's very similar to what you see in DNA. Now, essentially what you have is information. And this is something that's been recognized by many biologists and information theorists. And basically the idea is that the problem of the origin of life is equivalent to the problem of biological information. So the question becomes, where did this information come from in the origin of life? Or you could ask the question differently, where did the specified complexity of the amino acid sequence come from that allowed you to have a functional protein? And this is where Stephen Meyer had a brilliant insight. And his insight was that if you apply the standard methods of historical sciences to life, then you come to an interesting conclusion. Now, what is that method? Well, the method that was used by, let's say, geologists or even Darwin himself was the idea of multiple competing hypotheses. And the idea is that if you're looking at some event in the past, you ask yourself what processes that happen today can produce the effect to explain what you see in the past. Now, an example of that is I live in Washington, state of Washington, and if you go to certain parts of Washington, you see about several centimeters of ash. And if, let's say, you're a geologist, you go to this part of Washington, you ask yourself, how do we explain what happened in the past? Well, what you do is you look at processes happening today that have the effect of producing this ash in the past. And you could argue, is it from rain? Is it from erosion? Is it from farmers? And the answer is no. But what you recognize is volcanoes can actually produce that type of ash. So looking at the process of volcanoes producing ash today can explain this effect in the past. And in fact, if you look in the history books, there was in fact a volcanic explosion in the 80s. Now, what happens when you apply that process to the origin of life? Well, there's different ways you can explain the origin of life. One explanation is purely by chance. Well, as Douglas Axe will talk about, chance will not help because protein sequences are far, far too rare to explain by chance processes. Well, also, is it something that's produced by a natural law? Is there any natural process that will produce the information that you see in the cell or the specified complexity or the ordering of amino acids you see in a protein? And again, there is not. And I use the example of your alphabet soup, where you might have lots of letters in your soup, but if those letters form a message, there's no way to explain that by the chemistry of the pasta or the physics of the boiling water. And it doesn't matter if you're using alphabet soup today or a prebiotic soup in the past to explain the origin of that information in the cell. That won't explain it. Nor will the combination of chance and natural processes. However, we do know that there is a process that takes place in the present that creates the sort of patterns we see in DNA, and that's intelligence. Because what people realized is that if you look at information, information is consistently associated with an intelligent mind. So we know that minds regularly create information. They regularly create ordered sequences that carry out a purpose. So what we know is the only process that can produce information today is a mind. So it's reasonable to conclude that since no natural process could produce it in the past, that we can conclude that a mind produced it in the past. It's the inference to the best explanation with these different hypotheses. The same sort of logic used in geology. Now, what happens often is that people aren't asking themselves, what's the best explanation for what we see in life? They're asking the question, what's the best hypothesis, which is purely naturalistic? In other words, design is assumed to be false from the beginning. So it's ruled out from the start. So regardless of the evidence, regardless of the logic, they assume it can't be true because of that philosophical assumption. Well, what happens is you've got to ask the question, is that reasonable? Is it reasonable to assume that identifying intelligence is unscientific? Well, let me use an analogy or an example. What if you were a geologist and you were studying rocks and you come across something like this? Now, this is the Rosetta Stone, and the Rosetta Stone, it was the key to translate hieroglyphics, because on the stone, you have ancient Greek language, and you also have Egyptian hieroglyphics. Now, when someone sees these patterns and these letters on the stone, they're not going to conclude, isn't it amazing what wind and erosion can do? Isn't that stunning? And you would never hear a geologist say, you cannot argue for design because that's unscientific. It's unscientific to argue that this pattern in nature can be explained by intelligence. That's not allowed. You have to keep researching to find out how can wind and erosion produce that pattern. Well, no one would ever do that. It's completely irrational. However, they use that same logic with life. They say it doesn't matter if it looks designed. It doesn't matter if there doesn't seem to be any natural explanation. You still cannot include design. However, what happens is when you take off the shackles of that assumption, when you step out of the materialistic paradigm, what happens is the evidence for design becomes very clear by standard scientific logic. Now, the question then becomes, if we see design at the origin of life, do we see design throughout life? And the answer is that we do. Because if we go back to the origin of species, you go back to the tree of life, the logic is that over millions of years, these small changes you see in natural selection can accumulate to create very, very large changes. So maybe in a few years, you can produce a sheep with more wool, then perhaps over millions and millions of years, you can go from a fish to an amphibian. Well, as it turns out, this picture does not correspond to the actual fossil record. What you see is when you look deep into the past, you have life that goes all the way back to the origin of, or to close to when our Earth first formed. You have other creatures back here, but at a period roughly 500 million years in the past, you see the first representatives of most of the major animal types that we see today. They did not come about through a gradual process of slow transformation. we see no branches leading back to the origin of life. It looks more like intelligent design at this point, where information was infused into the system to produce new body plans. And this isn't surprising that you see so many dramatic new creatures at that time, and you concluded that it was produced by a designer, because if you happen to design computer programs, you know that if you want to give a computer a new function, like a word processor, you have to give it new computer code. You can't produce anything radically new without lots of new information. In the same way, when you look at new body plans, new architectures that appear suddenly in life, you know that that requires large amounts of information to be infused into your system. In other words, when you look at the process of the formation of life throughout history, you see consistent patterns of radical new life patterns forming suddenly in the fossil record, and then you typically see where the fossil record is highly complete, that a species essentially stays the same throughout time. That's the picture you see where the fossil record is most complete. Where the fossil record is highly incomplete is often where evolutionists argue that purely natural processes can explain what they describe as transitions and sequences. But the problem is what happens is you have lots of different creatures in the fossil record. Evolutionists aren't quite sure how the pattern fits together, but because the evidence is so fragmentary, they have room for their imagination to fill in the gaps, to imagine that there's slow, gradual development taking place. However, where the fossil record is most complete, you see the clearest pattern that life appears suddenly and then doesn't change. And anything new appears in short amounts of time, again suggesting that information is being infused into the system by an intelligent agent. Well, those are kind of a quick summary of the various arguments for design, but what's happening is that biology could very well be going through a revolution which is as dramatic as going from Newtonian mechanics to quantum mechanics, the great physics revolutions of the 1900s. Because what people are realizing is that the simple conception of life is probably not accurate. And that's the idea that you've got DNA with information that produces proteins, that produces the structures in the cell. What people are starting to realize is there could be information in the cell outside of DNA, in the structure of the cell membrane, in the skeleton system of the cell. And what can happen is the DNA works in conjunction with this other structural information in the cell in a very complex way to produce the different life forms we have. So this transformation requires for you to see life from the perspective of an intelligent designer. Because what you do not see is simply DNA producing proteins, producing the cell, but you see a very complex hierarchical structure where information is going in different directions to explain life, which all points to coordination, integration, and design. Thank you very much.